There we go. Ladies and gentlemen, this is going to be example how to do some of the example problems on the last assignment I gave you on transmutation reactions. So with no further ado, let's go ahead and start. Let me change my pen color to, let's see, something we can see about purple or magenta. All right, so with this, we don't know what this element is, or particle that's coming out. So let's take a look. Mass on the left is 97. Number of protons or atomic number is 43. We need to have, for this to be valid reaction, the mass number has to be identical. So the sum of 97 plus something has to equal 97. Well, we know particles are going to have a zero mass. And 42 plus whatever has to equal 43. So 42 plus 1 is 43, and then we have it's our positron. So our actual reaction is going to be 93, 43 technetium, Tc. We'll end up going to molybdenum 97, with a positron being emitted. And that is how we balance the reaction. Again, to be balanced, mass on each side of the arrow is equal. Also the atomic number. And that's the sum. I mean, if you only got one nucleus on the left-hand side, you only got one. If you got two, you got to need to take care of two. So let's use this principle now to solve this. We have something. Now, what we don't know is on the left-hand side, so we're looking for a reagent. So we're looking for this guy. We don't know what that element is, but we have everything else to solve it. So on the right-hand side, the total mass is 31. Total atomic number is going to be 15. So on the left-hand side the mass should equal 31. The atomic number should equal 15. So we've got an alpha particle, helium-2, helium-4. 31 minus 4 will give me 27. So if I do this 31 minus 4, that's going to give me whatever the mass is over here, and that should be 27. We have 15 for the atomic number. We have 2 already, so 15 minus 2 is 13, and this will be aluminum. So aluminum is our target, is being bombarded by an alpha particle, and we end up with a neutron being emitted with phosphorus being produced, phosphorus 30. And that is the reaction. So to rewrite it is 2713 aluminum plus 42He, and that will yield 10N plus 15 phosphorus, so phosphorus 30. And that is the balance equation. This is a transmutation reaction, ending up with a phosphorus being produced with a neutron being emitted. Now the other type we're going to talk about is this one, where we have 4 neutrons being produced. It's not a cascade, it is not a fission reaction, but it's a transmutation because we've got 2 nuclei coming up. Fission is when we bombard something with a neutron only. So that's the difference between fission and transmutation reaction. So what we have here is californium 249 being bombarded by oxygen 18, and we're going to get something being produced, and plus 4 neutrons. In the problem set, I will give you, if there's more than one neutron or other particle being produced, that will be given to you. So you don't have to figure out what that for is. So mass on the right, total mass, 249 plus 18. That should give me 267, I think. Yep. So that's the total mass on the left, the total atomic number. This is my abbreviation for atomic number. 98 plus 8, I believe that is 106. So 98 plus 8 will give me 106. 249 plus 18 will give me 267. Now, on the left, I have 4 neutrons, so I got 4 mass plus something. Whoops, I gotta go back. Sorry about that. Press something. Plus some. Plus something will give me 267. So that something is going to be 263. That's the mass number for my compound. So the atomic number, I got 4 zeros. So the atomic number is going to be 106. So my particle is going to be something 263, and that is Seborgium, Sg. So that is my answer. So it's going to be, rewrite it, 249, 98 Cf plus 18.8 oxygen yields 4 neutrons being emitted plus Seborgium 263. And that's how you solve these things. So realize that after all this is done, the mass on each side, total mass on each side should equal, and the total atomic number on each side should be equal. This is the breaking point. This is before, this is after. So this is before, and this is after. That's the way you should look at these arrows. Now you'll have a Google spreadsheet to fill out that will tell you if you're right or not. Make sure before you turn it in, everything is green. Thank you, ladies and gentlemen.